In this second video on exam style questions, we are going to concentrate on MCQ, multiple choice questions, and go through the variety of multiple choice questions that can be asked on the rate equation. I'm going to start with a multiple choice question, which I'd recommend that you stop the video and read first. But in this MCQ, you can see I've got a rate equation at the top. It's asking me what is the effect on rate of reaction if I change concentrations of the reactants. And it gives us some options. So we put this to the side and highlight the main areas. We're highlighting the changes we're looking at, and we're highlighting this rate equation generally. So if you look at the rate equation, you can see NO has a 2 by it. So that means if we look at NO, NO is going to be second order. Okay, so second order. If we then go to O2, so O2 has no number by it. If you look in this rate equation, there's no number right here, which means that is first order. So we found out what our orders are, and we need to go from there and think about what the changes would be. So if I'm looking at that, second order means that, for example, if we've got here, we know that the O2 is halved and the NO is doubled. So the NO is doubled. So that means if the NO, and that's the concentration of the NO, is times by 2, because we know the NO is doubled, we know it's second order. So what do we think is going to happen to the rate? Okay, so what do we think is going to happen to the rate? Well, second order means that the rate will change by the square of the change in concentration. Well, the change in concentration is times by 2. And if the change in concentration is times by 2, square of 2 is times by 4. So our rate is going to be times by 4. We then go to the O2. And the O2, it says, is going to be halved. So that is going to be divided by 2. If that is divided by 2, and we look at the rate, we know it's first order, so it's proportional relationship. If we divide the concentration of O2 by 2, then we will divide the rate by 2 as well. Now, if I divide that by 2, it's also saying I'm timesing it by 0.5. So instead of saying divided by 2, what I'm going to do is I'm going to say times by 0.5. Now, if that is the case, and it's timesing by 0.5 and times by 4, all you have to do is take the numbers and times them together. So that means the overall effect on the rate is going to be 0.5 times by 4, which is equal to 2 times and 2 times the rate. Okay. So we've taken the orders, we've then found out what's going to happen to the rate as a result of those orders. We know it's going to divide by 2, but that's the same as timesing by 0.5. So we're taking 0.5 times by 4, get 2 times the rate. So that eventually means you can go down over here, and you can see, if I could just peek through the hole here, you can see that one of these, is it doubled? Yes, it is. So that one is C. So this one is going to be my correct answer. The reaction rate is doubled. Our second MCQ is about recognizing the correct order graph. So they will ask you to recognize a type of graph, and this time they want a time concentration graph, and they want it for a second order reactant. And they won't include the axes to make it a bit more difficult, which is why I say to you, you must remember the shapes of all these graphs. So if we look at the first one is zero order, because if you look at it, it's classic for the concentration increasing and the rate stays the same. We then go to the next one, and we can see we've got this decreasing line. Hopefully you remember that is also a zero order reactant, but it's a time concentration, whereas this one is a concentration rate. Okay, so this is a time concentration. We know both of those are not the correct answer because they're both zero order, and we're looking for second order. So this one, hopefully you can see this is a second order. Okay, now that second order means that you've got concentration rate And we're not looking for concentration rate, we're looking for time concentration. So that must be the last one, which is time concentration, and it's second order. So again, what we've done is we've had 2 zeros, 2 seconds. So they're trying to get you confused by putting the same order graph, but in different types, either concentration rate or time concentration. We're now on to our final question, which is a MCQ. Given an equation, and we're given the rate constant, and we're given the units of the rate constant. So you have to derive the overall order of the reaction from the units of the rate constant. So this is key. And this has appeared, like I say, in exams before and could easily just be adapted again. So let's put it over to the side, okay, and try and figure out how to do this. So let's think about the equation itself. So it's going to be rate, and it's going to be rate equals K, and to the concentration, for example, of our reactants. So it could be H2O2 or 2I minus. We don't know whether one is 0 order, one is, and we don't know this part. But what we do know, if you rearrange it, is rate is divided by this, okay, and that will equal K, and therefore that will equal the units of K. So at this point, we know our units of K are decimeter, moles, -1, seconds, -1. Well, seconds -1 comes from the rate. And if we put moles, dm cubed, seconds -1 at the top for our rate, and then we start to think, how can we get decimeters to 3 moles, -1 seconds to -1? Well, to do that, if you look at it, it is 1 unit in terms of moles per decimeter cubed, but it's moles per decimeter cubed the wrong way around. Remember, your units for concentration are moles per decimeter cubed. So that's your normal unit for concentration. So if that's your normal unit for concentration, that is exactly the same, but it is times by -1. You can see the mole has been converted to, well, that means there must be a moles per decimeter cubed down here. There must be a moles per decimeter cubed down here, and there must be a spare one. So let me just put that into, hopefully make that make more sense. Okay, so that must mean that, think about it, if I put 2 of them down like this, that will cancel, and that will cancel. Does that make sense? That will cancel. Right, and that leaves me with 1 behind. Because there's only 1 moles per decimeter cubed at the top, okay, and we only have 1 moles per decimeter cubed that's been converted into the final units, then you can only have 2 moles per decimeter cubed at the bottom, because you need that spare one to be times by -1 to come up to do that. So if that's the case, what that tells us is that we have 2 reactants underneath here. Let's put it out here. So we have 2 reactants that's up here. And we also know that both of those reactants are to the power 1, or we know that we've got 1 reactant and it's to second order. So it's either 1 reactant to second order or 2 reactants to first order. But if it's second order, we'll get 2 of these units. If it's 2 first orders, we'll get 2 of these units. We don't know which one it is, but that's a suggestion there. So we then go to the question, says, what's the overall order of the reaction? Well, we know it's either a second order here or it's 2 first orders, so all you have to do is add the 2 orders together, and therefore, if it's second order only, it would be 2, and if it's 2 first orders, it would be 2. So the answer is going to be 2. And it's a really good one. If you get used to this, it's really, really quick. You can just see straight away, look, there's 1 remaining underneath there, one will cancel out, and therefore I have 2 of these units, and therefore the overall order is 2.